Hello everyone, welcome back to my YouTube channel. In this particular video, we'll be looking into how we can solve this problem using Girvan Newman algorithm. So basically, we have to find out the betweenness centralities of each and every edges in this particular graph. Also, have been getting different messages from you guys that you guys are finding it difficult to solve this particular problem. So here is the video. And before that, please do like and subscribe to my channel if you are new to the channel. So let's start. So basically, we have to find out the betweenness centrality of every single edge inside this particular graph. So if you remember, I have already created a video on Girvan Newman algorithm where I have solved one problem step by step. We are going to follow the same way. We'll have to find out the betweenness centrality of every single edge with respect to keeping each and every node as the root node one by one. So let's start with the node A. So let's keep now the node A as the root node. So now keeping the node A as the root node, we have to form a tree-like structure. So here A is the root node and you can see that A has two children. So B and C will write it like this. Next, you can see that C and B are also connected to each other. But in the in this particular tree, they are at the same level. So we will display it with a dotted line. Now moving forward, you can see that B has a child D. You can see over here, D has three children E, F and G. So let's write that. And you can see that E, EF and FG are connected with each other. So let's again show their connection with the dotted line. So this is the tree-like structure that we have created by keeping the root node as A. So now the next step is to calculate the weights of each and every node. Now this particular weights is nothing but the total number of shortest path from the root node to reach that particular node from the root node. So you can see over here that for reaching from root node A to A itself, there is only one single shortest path. For reaching node B from root node A, there is only one single path, that is AB. Similarly, for C, there is only one single path to reach from root node A to C. Similarly, we have to find out for D also. So there is one single shortest path, that is A, B and D. Similarly, for E, it is one, that is A, B, D, E, and for F also it is one. For G also it is one. Now once we calculate this, next we have to find out the betweenness centrality of the edges. So as per the rule, we have to start from the bottom, that is from the leaf node. So first we'll calculate the betweenness centrality of the edge DE. So since E is a leaf node, we have to calculate the betweenness centrality by simply dividing the weights of the parent node from the leaf node. So 1 divided by 1, it gives us 1. So 1 is the weight of the node DE for this particular graph. Similarly, for DF, it is again 1 divided by 1. So again it is 1. Similarly, for DG also, it is 1 because 1 divided by 1 is 1. Now, for BD, now note one thing that D over here is a non-leaf node. For any non-leaf node, we will have to consider the edge centralities of the edges which are connected to its child. That is, you can see DE, DF and DG are these three edges which are connected to node D. So we have to add all of them. That is 1 plus 1 plus 1. That is 3. And we'll also have to add the weight of this particular node D. So there are total 4 ones. So it gives us 4. So I hope you are getting it. Similarly, now for the edge AB, you can see that B is a non-leaf node. So below that, there is only one single edge which is connected to node B. So the edge centrality is 4. You have to add this particular centrality with the node weight of B, that is 1. So 4 plus 1 gives us 5. Similarly for AC. Now you can see over here that C is a leaf node. So for any leaf node, there is a rule that we have to divide the weight of the parent node from the weight of the leaf node. That is 1 divided by 1, it is 1. So we have calculated the between the centrality of every single edge by keeping the root node as A. So I hope this thing is clear. Now note one thing that the nodes which are at the same level, their between the centrality will be 0 because they are at the same level. Similarly for EF and FG, their between the centrality will be 0, so we won't consider that. So I hope this thing is clear. Now similarly we have to calculate for all the other nodes. Now we'll keep the root node as B. So over here you can see by keeping the root node as B, we can have three direct child A, C, and D. So let's write it A, C, and then D. You can see A and C are at the same level and they are connected to each other. Now, when we talk about D, D has total three children E, F, and G. So let's write that E, F, and G. Now, over here you can see that E and F are connected as well as F and G are also connected. So that's it. Now we'll have to calculate the node weights of every single node. So here you can see the node weight of the node B is 1 because there is only one single shortest path to reach from node B to node B itself. Similarly for BA, there is one single shortest path to reach to node A from the node B. For node C, there is only one single shortest path to reach from node B to node C. Similarly for D also it is 1. Similarly for E, F and G also it is 1. So that is why 1 I have written over here. Now next step is to calculate the edge betweenness between all the edges. So we'll start from the leaf node. So over here you can see that for DE, it is since it is connected to a leaf node, so we'll have to divide it. 1 divided by 1, it is 1. Similarly, for DF, it is 1 again. For DG, it is 1 again. Now, when we talk about BD, over here, since B is not a leaf node, that is why we'll have to consider its connections with the child node that it has. So there are three child of B. The edge between the centrality of every single edges that are connected to node D from their child are 1. So 1 plus 1, it is 3. And we'll also have to add 1 to it. That is nothing but the node weight of D. So 1 plus 1 plus 1 and plus 1. It gives us 4. Now when we talk about AB, it is 1 again because A is a leaf node. For BC also it is 1. So I hope this thing is clear. Now similarly, let's move on to node C. Now let's keep the C node as the root node. So now over here you can see C has two child A and B. So let's write that C, A and B. If you remember, A and B are connected to each other, so let's show it by the dotted line. Next, B has a child D. So let's write D. D has three children E, F, and G. Let's write that. E and F are connected to each other. They are at the same level. Similarly, F and G are also connected to each other. They are at the same level. Now, we are done with the construction of the tree. Now let's find out the node weights. So the shortest path from C to C is 1. The shortest path from C to A is 1. The shortest path from C to D is 1. Similarly for D it is 1. For E, for F and for G it is 1. Now let's calculate the between the centrality of all the edges starting from the leaf node edges. So over here for DE, since E is the leaf node, that is why 1 divided by 1 will do and it is 1. Similarly for DF it is 1, for DG it is 1. Now for BD, since B is a non-leaf node, if you remember for non-leaf node, we have to consider the child node edges. So over here you can see we have to add all the edges, that is 1 plus 1 plus 1, and we also have to add the node weight of the node D, that is 1. So 4 is the answer. So BD weight is 4. Now let's move on to AC. Since A is the leaf node, that is why we will have to divide this. 1 divided by 1, it is 1. For CB now, over here look that B is not a leaf node, that is why we'll have to consider its child edges. So over here there is only one child of B, that is D, and the edge weight is 4. We have to add the edge weight with the node weight of B, that is 1. So 4 plus 1, it is 5. So this is the answer. So we are done with the node C. Now let's do it for the node D also. Do you want to check out this attractive funny memes? Then what are you waiting for? These are just a glimpse of the memes that I've created on my Instagram page. You can find the link to my Instagram handle in the description box. Please visit the link and do watch all these interesting funny memes. These are not just memes. These memes and reels contains technical information. Here I try to relate memes with the technological concepts. So please do appreciate that by watching all those. And if you love it, please hit the follow button. Now this time, D is the root node. D has four children, B, G, F, and E. So let's write that. Now, if you remember, in the graph, B has two children, A and C. And these two children are interconnected to each other. Now, when we move on to the node G, F is present at the same level of G. So we'll connect it. Similarly, F and E are also connected to each other at the same level. So I think we are done with this particular graph. Now, once we are done with it, we'll have to calculate the node weights. So that is the shortest path. For from D to D, it is only one single shortest path. From D to B, it is one. From D to A, it is one again. From D to C, it is one again. Now, when we talk about D to G, it is one. Similarly, for D to F, it is one. For D to E, also it is one. Now, let's calculate the edge betweenness of all the edges. So over here, let's start with the leaf node, that is AB. So since it is a leaf node, 1 divided by 1, it is 1. Similarly, for C, it is a leaf node, it is so 1 divided by 1, it is 1 again. Now for BD, since B is a non-leaf node, so we'll have to consider its child edges. So over here, it is 1 and 1. So 1 plus 1, it is 2. And then we also have to add the node weight of B, that is 2 plus 1 is 3. So let's write 3 over here. Now for G, F and E, all these three are leaf node. So simply write 1 divided by 1 is 1, 1 divided by 1 is 1, and similarly over here. So this is what is the graph for node D. Now similarly, let's do it for the node E. So now for node E, we'll have to consider E node as the root node. So here you can see that E has two children, D and F. So let's write it. Now, if you talk about F, F has one child, that is G. D also has the child G, as well as B has child B. So we'll have to write it something like this. There is a common child between D and F, which is G. And there is also one more child of D, that is B. Over here, you can see that B again has the children A and C. A and C are at the same level and they are connected to each other. So this is what is the graph looking like. So, and remember one more thing, that D and F are also connected to each other, but since they are at the same level, so we'll show the connection with the dotted line. Now let's calculate the node weights. So for E it is 1, for E to D it is 1, for E to F it is 1. Now if we look carefully, for reaching from node E to node G, we have two shortest path, that is EDG and EFG. So the node weight of G is 2. Now for node B, for reaching from node E to node B, it is only one single shortest path. Similarly for node A, it is 1. Similarly for node C, it is 1. Now once we do that, we'll have to calculate the edge between the centrality. So over here you can see that we'll start from the leaf nodes. So since A is the leaf node, so the edge between the centrality of the edge AB, it will be 1 divided by 1. That is nothing but 1. Similarly for BC also it is 1. Now, B is a non-leaf node and we have to calculate the centrality of the edge DB. So, it will be 1 plus 1 since we have to consider these two also. So, 1 plus 1 and the node weight of the node B is 1 again. So, we'll have to add all these three. So, it gives 3 as the answer. Now, look carefully. We have to now find out the edge between the centrality of the edge DG. Over here, you can see that the node G weight is 2 and the node D weight is 1. So, since G is the leaf node, we have to divide it. So, 1 divided by 2, it is zero point 0.5. Similarly, for F also, 1 divided by 2, it is zero point 0.5 because G is the leaf node. Remember this. Now, when we talk about DE, for this particular edge, since D is a non-leaf node, we'll have to consider its child edges. So here for D, there are two children, B and G. And the edge that is connected to these two has the value 3 and zero point 0.5. So 3 plus zero point 0.5, and we also have to add the node weight of the node D, that is 1. So 3 plus zero point 0.5 plus 1, this gives us 4.5. So edge centrality of DE is 4.5. Now similarly for FE, here F is a non-leaf node, we'll have to consider its child edge also. So over here you can see zero point 0.5 is the edge centrality of the node F to its child, and the node weight of the F node is 1. So 1 plus zero point 0.5, it is 1.5. So I hope this thing is clear. We are done with everything now. Now let's move on to the next node, that is node F. Now we'll keep the root node as F. Here you can clearly see that F has three children, G, B, and E. So let's write it. Here you can see that GD and BE are connected to each other. So let's show it by a dotted line. Now further, B has a child, B. So let's write that. And B has two children, A and C. Both of these are at the same level, but they are connected in the graph. So let's show it by dotted line. Now, the next thing we have to do is to calculate the node weights. So it's simple, right? For F, it is 1. For G, it is 1 again because FG is the only shortest path. For D, it is 1. For E, it is 1. For B, it is 1 again because there is only one single shortest path, that is FDB. For A, it is 1. For C, it is 1 again. Now we have to calculate the edge centrality. So for AB, since this A is the leaf node, it will be 1 divided by 1. So it is 1. For BC, it is 1 again because C is the leaf node. For DB, since B is not a leaf node, we'll have to consider its child edges also. So there are two child of B node, 1 and 1 is the edge weight of it. So 1 plus 1, and the node weight of B is 1. So 1 plus 1, it is 3. Now when we talk about the edge FG, since G is a leaf node, so 1 divided by 1, it is 1. For node FD, since D is not a leaf node, you have to consider its child node edge also. So it is nothing but 3. 3 plus 1, which is the node weight of D. So 3 plus 1 is 4. Similarly, for FE, since E is a leaf node, that is why 1 divided by 1, it is 1. So this is what is the tree looks like. Now, we also have to do it for the last node, that is node G. Now, this is kind of a task for you. You have to do it for the node G by yourself because I already have shown you from A to F. All the nodes, we have constructed the tree for it. So this is how it will look like. Please check this with your answer, what you got. Now, once we do it for all the nodes, now we have to construct the table. The table which will sum up the betweenness centrality of every single subsequent edges and will get the total value of every single edge. So this is the table. You can see over here we have written all the edges that are present inside our graph. A, B, A, C, B, C, something like this. Here you can see edges. A, B, A, C, B, C, BD, BG, BF, BE, EF, and GF. These are the 9 edges that are present inside our graph. And apart from that, I have written over here as the columns as the nodes that we have considered as the root node every single time. Now, once we do this, after that, we also have to write a column of total. That is, we have to add the subsequent values of these edges with respect to every single node. So now when we talk about the edge AB, so how to calculate this? We have to look for edge AB in each and every graph. So when we talk about the A node as the root node, so edge AB was having the value as 5. So we have written 5 over here. Similarly, in the graph of the root node B, the edge AB has the weight 1. So we have written it something like this over here, 1. Now in node C, if you look here in the graph which has the node C as the root node, the edge AB was at the same level. So its betweenness centrality will be 0. So let's write 0 over here. And similarly, we have done it for every single graph. We have to do it for all the edges and we have to write the values of it in this particular table. And once we do that, then we have to sum up the rows. So over here you can see 5 plus 1 plus 0 plus 1 plus 1 plus 1. This gives us 10. So the summed up edge between the centrality of the edge AB is 10. Similarly, for AC it is 2, for BC it is 10, and so on. So this we have to calculate. Now, if you remember inside the graph that we have got in the problem statement, here every single edge is bidirectional. There is no arrow which is pointing towards a particular node. So that is why this is bidirectional. And when we talk about bidirectional edges, their betweenness centrality has to be divided by 2. So whatever value we have got over here, we have to divide it by 2. So 10 divided by 2 is 5. Similarly for 2, it is going to be 1. For 10, for 24, it is 12. For 9, it is 4.5. For 8, it is 4. For 9, again, it is 4.5. For 3, it is 1.5. And for 3, again, it is 1.5. Now, this is the finalized value that we have got for every single edge. Construct this particular graph again, and then you have to put the values. And over here, you can see that the value of the edge AB is 5. So we'll write 5 over here. Similarly, for AC, it is 1. For BD, it is 12. For DG, it is 4.5. For DF, it is 4. For DE, it is. So this is how I have written the values of every single edge that we have got as the value from the computation that we did. So this is the finalized graph. Now over here in the question, it was only asked to find out the betweenness centrality of every single edge. So this is the final answer. But if they further ask you to find out the communities from this particular graph, then in that case, what you need to do is you need to find out the edge with the highest weight, that is, which has the maximum value. Over here, you can see that BD has the maximum value, that is 12. So you have to eliminate that particular edge. And since this is eliminated, these two parts are now separated. So over here, you can see that this is one community and this is another community. So this is how you have to find out the communities. But since in the question it was only asked to find out the edge between the centralities of every single edge, so we'll keep it like this. We have solved this entire problem step by step. If you guys have any single doubt, then you can straight away put it in the comment section. I'm sure you won't be having any doubt because I've tried to clear every single step. If you guys like this particular video, please do like, share, and subscribe to my channel. Also hit the bell icon and don't forget to follow me on Instagram. Please join me on Telegram and thanks for watching. Have a good day ahead.